First of all, thank you for your books, because I've read a dozen books on pyramids, ancient Egypt, and stuff like that. And yours, you don't put things through your own interpretations. You're showing us the facts, the measurements, and you're letting the reader come up with their own interpretations, as opposed to filling the book with, magic and all this stuff, which is, I think, what Egyptologists and, dare I say, woo-woo people have in common, is they sprinkle magic over everything to make it mysterious or occult. And you're over here like, we don't need to sprinkle occult stuff on these things. They're already mysterious. They're already very strange. And reading these books, I enjoy how I can take the tour with you as you're discovering these things, because you talk about what you experienced as a machinist when you first saw those things. And to see these Egyptian mysteries, or any mysteries, through the eyes of a tradesman, of which I too am a tradesman, I find that to be extremely valuable. How would you say that being a tradesman, a lifelong tradesman, has affected your way of viewing the great mysteries, especially Egypt?
Well, everything really. I mean, just understanding how machines operate and operating machines, things of that nature. You are bound to a certain discipline, which is precision, accuracy, repeatability, working with geometry, and also the limits of the machine. But plus that, you have the group of people generally that you're surrounded with, who are your teachers.
Right.
So the thing that I have benefited from is that I'm not just a guy on an island, right?
That's important.
I'm surrounded by similar-minded and skilled people, engineers, machinists, tool makers.
It's almost like you have two different worlds, because you talk about when you told your boss, your old boss, about, I need 2 more weeks off, I got to go to Egypt. He's like, why? And you showed him. He was like, I'm coming with you. And then so you got that world, and then when you actually go to Egypt, you got great company too. You brought a bus or whatever of your
Judd Peck, his name is.
Yeah.
He's the CEO of Danville Metal Stamping, and so that's a fairly decent sized company. I mean, it's almost 500 employees. Been in business for 79 years.
Right. So that keeps you grounded, as far as when you're looking at something like Egypt, it'll make your brain go into overdrive, and next thing you know, your people will be talking about aliens and stuff, and you're like, well, in Giza, Tesla Connection, you talk about, when I look at something that's been machined, whether it's a statue or a mouse for a computer, I don't just see, what you said, I don't just see the mouse or the design or the car. My mind takes me to a machine process. And then, frankly, you can break down how this design came to be. They used a plastic mold or whatever, blah, blah. But when you see things like Saqqara or Ramses, you're that mindset, all of a sudden you're like, okay, the machines that we're familiar with don't do that.
I wouldn't go that far. I wouldn't go as far as to say that. We could machine a Ramses
today.
It would be a very large machine, probably robotic.
Right.
And with a range of tools that you don't normally find in your average machine shop.
Like you said, in Giza, in the Tesla Connection, there's no reason for us to assume that their machines would be the same as ours.
Right.
You're not saying that they're more advanced than ours. They would just be strange. They'd be...
Well, the thing is that I've learned through being employed in many shops, maybe about 13 shops total, that each shop that I go in, I learn something different. And then going to trade shows and seeing how, people who are selling their products, selling their new machines that that are performing in ways that I haven't seen before. And so, you learn that way is that you cannot assume that just because you can't figure out how something is made,
Yes.
that there isn't some engineer somewhere in the world who have figured it out and are doing it or could do it. So I never say that it can't be done today. It's just that we haven't decided to invest the money to do it. The thing is that along with that, I have, when you talk about a peer review process, right? And so everybody's, you have to be peer review. Everything that I have written has been peer reviewed.
Right. See, I love that.
Right? And so it's kind of like everything that I've done, I have talked to fellow engineers, this is what I'm thinking, what do you think? And even when we have the debunking videos that have come out against lost technologies,
I have not seen many of those, but
well, I can give you a nice healthy list for you to.
I read you respond to some of them, especially in Tesla Connection.
Right. Yeah. So, there has been a huge backlash. I wouldn't call it a backlash, but I think it's very worrisome now for archaeologists, Egyptologists, because of, people like Graham Hancock, like myself, Robert Schoch, we have a different point of view. And, they're losing market share. And they're losing funding. You follow the money, right?
Yes.
So it's like there's another product out there that people are tuning into, and they prefer it to the old orthodox stories.
Needs a revision desperately.
And they hate it.
Right.
Oh, they can't stand it, right? So there's been, a pushback, and there has been a series of videos that have been created. Taking on my work. They call me a liar, they call me a grifter, say I'm just doing it for the money.
You had a list in there, and one of them was fruit cake or something like that.
Yeah,
You're like, I couldn't help but notice that one. It's interesting.
Right, yeah.
Which at a certain point is just name calling. That's when you run out of good points.
Yeah.
You get the name calling happening. But
well, yeah, fruit cake.
Right.
The whole accusation that you're pseudo. So you have a historian, who is commenting on engineering matters.
How does that
and
work?
calling me a pseudo archaeologist, which I've never claimed to be an archaeologist.
Right.
I won't want to be an archaeologist.
There's two different realms here that they meet in the middle, and that's where your work comes in. And like you said, it takes a machinist to recognize a machine. How would an archaeologist in any way, shape, or form see a catalytic converter and then know how that works and what that does? They dig in the ground, and I have respect for what archaeologists do, but their job is to bring us the relics. And it should be a machinist's job or a geologist's job to date it, all this stuff. My favorite response to one of the debunkers that you have in a Tesla Connection, if there was hydrochloric acid coming down this shaft, then the stones would be corroded. And you said, yeah, they sure would be. And they are. And I love it. That was a beautiful moment where you're like, it's because they're coming at you with everything they got.
Oh, right.
But with that particular little debunk, they actually validated your own claim.
Right.
Well, which I don't even know if that's your claim, because the shaft is corroded.
Yeah.
It was
exactly.
There was acid in there.
Yeah.
I'm astonished by what Egyptologists will make up. One of them was the smell that comes from the Queen's chamber was from people urinating in it. Right?
It's a long way to go for a fish.
It's a really long way to go. And not only does it not make sense, but why are people targeting that area? From what I've read, it smells like ammonia or whatever.
Well, I haven't smelled ammonia in the Queen's chamber. There is a strong smell of it in the Bend pyramid, or the Red pyramid rather.
Gotcha.
At Dashur. So. But they've pretty much cleaned up the Queen's chamber.
Yeah, they cleaned it up. How do you feel about whenever Hawass cleans up the pyramids. I mean, is this wholesome? Is this something that he's doing for the tourists to have the best experience? Or is there something out there that he needs to get behind closed doors?
Well, that's an interesting question. There was a lot of rumors back. I mean, the internet was abuzz when they closed the pyramid back in, when was it, 2000, 2001, somewhere around that period of time. So there was all kinds of rumors. Some guy claimed that Hawass was digging a tunnel over to the Great Pyramid so he could get behind Ganton Brink's door,
right,
to take a look and, change things around a little bit.
Well, they certainly knew how big that room was.
Well, that's
right.
Isn't that interesting, though? Yes.
That's fishy.
It's fishy. Yeah, it does have a little stink to it.
Yeah.
But the truth of the matter is that when I was there in like 1999 and going through the Great Pyramid, the Grand Gallery was a dusty old place. I mean, you could see the walls; they were coated with dust and muck. And in 2001, Zahi gave us permission. I was with Grizzly Adams Productions, and we were filming on the Giza Plateau. Paid him a visit, and he gave us permission to go into the Great Pyramid, which was closed at the time, and also the Serapeum. So that was the first time that I had actually, that's where that one photograph was taken in 2001.
With the square?
With the square, yeah. So anyway, but the in the Grand Gallery, that was remarkable because, yes, they were in there cleaning, definitely.
Yeah.
You could tell the difference.
Right.
But what it revealed was something that supported the theory in the Giza power plant. It was covering up for the most part, the scorch marks on the ceiling.
That's right. Oh, yeah.
And so, with it all cleaned up, those scorch marks became clear as day.
Right.
And I took photographs of them, and they're in Giza, the Tesla connection.
Right.
But those scorch marks in the Giza power plant, I proposed that there was an explosion inside the king's chamber because the walls had been pushed out. Yeah.
What kind of force does it take to move 100,000 tons?
Well, there's a lot of tonnage there, right?
Those stones are not malleable, so to speak. I mean, so let me throw this at you here. The only thing I can think of that would have that kind of effect would be is if there was a global cataclysm of some kind or another, solar flare, comet, I don't care which it is. But if the pyramid is harvesting the energy from the vibrations of the earth, that kind of cataclysm would send a machine like a transducer into overdrive. All of a sudden it's not doing the ohms that it needs to, squeeze the right energy.
Well, yeah.
That would make the pyramids older than the Younger Dryas cataclysm.
Yeah.
So that's where we get a little tricky there, right? I mean...
Well, it's all controversial if you compare it to the conventional model. And people who are researching different parts of it, like Robert Schoch and Randall Carlson, the Younger Dryas impact hypothesis, they have... they receive a little heat for their ideas. But if you look at just the reality of how vulnerable we are, I mean, we have no problem today talking about what would happen if a comet struck or an asteroid, or there was a solar flare or a solar mass ejection. So we have no problem with that, and the scenario is dire. It will be an extinction event for the world. Right. And there have been extinction events before.
Right.
And
it's like they block out only that one.
Right, but it's kind of like, so what we're saying now is that we can't say that, hey, before this extinction event, there was a civilization that was thriving just like ours was thriving today. And just like ours would disappear overnight if there was an extinction event today, they had a civilization that had fully developed, and most of that was disappeared. And what we have left are just the skeleton of that civilization, which are the stones.
It would make sense that thousands of tons of granite is the only thing that survives.
Right.
Especially when you and I both know that machinists and tool makers and people who build things, they don't leave their tools on just sitting around on site. And because they recycle the tools into other tools, or they take them with them.
Right.
And people say, where were the tools?
Right.
Even if they did leave them on site, they're not going to survive. They're going to rust and then wither away, where those pyramids are going to stay there no matter. And I've always thought if the pyramids were maintained, they could be well over 12,000 years old, and I have no issue with that. And in fact, it kind of makes more sense in that way.
Right.
Because with the hydrogen meltdown, which might be the wrong terminology for it, but we can see there's no hypothesis here that the stones were plumed out from the center of the pyramid. Something enormous had to do that. And the only thing that we can think of in the remote past that would be that powerful was the Younger Dryas era, where we see the geology everywhere else at that same time. Right. So
well, whether it's definitely I believe that there was an impact, several impacts, probably a storm of impacts coming in, and I think it does answer a lot of questions. I mean, when you're looking at, how long does it take for like ferrous materials to erode, rust away, and disappear?
Metal goes pretty quick, dude.
Goes pretty quick. Right. I mean, there's some issues with like exotic metals, but we don't know what kind of metals they were using.
We don't even know if they used air pressure or hydraulic cutting. Maybe it was because
I wouldn't put anything past them. I wouldn't put any technology past that civilization.
And that's what fascinates me is to cut granite to be as flat as it is. You talk about it's a pneumatic drill.
Well, vibrating sonic drill,
which uses high frequency sound.
High frequency, could be ultrasonic or less. We do it today on a smaller scale.
So a good question that might come out of that is, we see that they were using tools that were very exotic to us, but that does not mean aliens. That by no, so people, it's older than we thought. People go, aliens. They're using strange hydraulic tools or strange levitation with sound. Aliens, right? Every time someone comes out with a new thing, Ancient Aliens, Braley Carson, they're all really quick to be like, okay, it's different than we thought, so aliens. But you're out here saying these were the ancient Egyptian people, and they were not too different from us. They were far more advanced than we give them credit for. We don't have to go far reaching into the heavens for an explanation here.
Yeah. Well, the Egyptians themselves are now wrestling with that question. And an engineer colleague in Egypt, Ahmed Adli, Egyptian engineer, he's been following my work and spreading it, and also doing his own independent studies. Of course. Created a YouTube channel. And so, now the Egyptian youth are really inspired by his work, and also a lot of scientists, professionals. Not Egyptologists so much, but even Egyptologists, except the one we all know and love.
Wait, he accepts what? Which part?
The tomb theory is dead.
Really?
Yes. Yes, they're now saying, well, they're looking at their own history, or what they knew about their own history before Westerners came into Egypt and rewrote it and handed it to them. Say, okay, this is the history of Egypt, and I don't care what you say, but this is what we think.
Europeans, tourists, basically.
But their history goes back 36,000 years, something like that, or even further back than that.
I think getting Hawass in the position that he's in is a sharp move on the account of the establishment, because he's Egyptian.
Right.
I don't know if that was on purpose or not. I know he's been removed for whatever reasons in the past, but him being an Egyptologist who is Egyptian is actually strange statistically.
Yeah. Well, there is formal power and then informal power.
Okay.
So, if you're working in a shop, right, you may have somebody on the shop floor who has more power and authority to get something moving than the supervisor or his manager.
So many things are coming to mind right now. I know a couple guys who they're running the job, but then this guy comes on. He's been doing it for 30 years, and he don't want to run work, but now he's running work. He's running the job. Right. The guy's going to him, say, what's the next move? Right.
I mean, that's the way it's always been. Right.
Well, and that actually brings me to on the job site in construction. There's kind of a loose phrase that is used, which is, well, no one's going to see that. But Ramses, however, there is perfection in these statues that are well beyond anyone's eyes. In the Saqqara boxes, you brought up the point, why is the presentation, what they think is going to be the presentation on the inside of the box is covered with a lid, and the rest of the I don't want to say tomb, but is dusty and left rough.
All right.
That is extremely strange. What was going through your mind the moment that you realized that throughout Egypt there is perfection that can't be seen it was never meant to be seen?
Well, yes, I mean, everything that I observed and measured in Egypt came as a surprise to me. I mean, going back to 1986 when I first went to Egypt, I had no interest in statuary or anything like that in 1986, or even following that. It was like...
I can tell, too, because the change of mood between these two books, I didn't know that this was your first one, right? I thought this was. So I picked this one up, and this is damn near poetic, because this is like just stark, no nonsense. And here you have reverence in your words. You are, this is like the moment that you realized that there is something deeply spiritual and mysterious about this.
Well, I was shocked. I mean, I was absolutely blown away by what I found. But it wasn't like it all came at me at once. It was like peeling back the layers of an onion. Right. My first encounter with the Luxor Temple was in 2004. And the tour guide was off talking about the walls and the hieroglyphs and stuff. And I was looking at these granite crowns, these perfectly shaped crown, the white crown of Egypt. It's like, okay, I'm going to check that out. Yeah,
that's where an engineer is going to drift, because as far as we know, those hieroglyphs might have been added later. There's no way to know. But that's kind of where I want to take this. I want to talk about Ramses. Everyone has heard me drone on for an hour and a half about the Great Pyramid and the power plant theory, so we can touch on that a bit. But Ramses.
Okay, let's focus on Ramses.
Let's talk about Ramses. The headdress, this bowling pin, that seems like it can only be done with a lathe, but is only connected to, well, okay, please.
No, I mean, it doesn't seem like it does have the precision of a machine.
Right, because it's symmetrical from the front, and it's symmetrical from the side, and all angles around it.
Right. And when I first started to look at the crowns, I was thinking, okay, so how would they create this? Because the quality of the surface, it's like running your hands over it. It's like, a finely machined die with no dips, no tool marks, there's nothing. Everything's really smooth. And so actually photographing it and checking it for symmetry to see if one side matched the other.
Right.
That was where I first started to connect with the symmetry at Luxor.
When you took the photograph of Ramses and then you 180 it, and then you add a transparency to it, 50% transparency,
right?
And then you put it back on top of the original photograph,
right?
And there are no blurred lines on the cheeks, eyes, lips, mouth. The only blurred lines are on the outside where you have your arms. Your arm is because you have your arm sticking in, and to prove that it was an overlay, you're on the other side as a mirror image.
Right.
Everything in the photograph is blurry except for the facial features of Ramses.
Yeah, there are some imperfections on the alignment.
Okay.
Which is what I want to talk about.
Okay.
And demonstrate with this fellow right here. Getting just the right shot. I was the objective was to be able to angle the camera so it dissected completely through the head, so through the nose, so you create a plane, and we'll call this the x-axis.
Okay.
This the y-axis, and down would be the z-axis, right?
Okay.
So I was interested in the rotation.
Yeah.
Okay. And actually, when I first photographed Ramses, I had a handheld camera.
Okay.
And there was enough in that, in those photographs, when I was doing the flip to compare one side with the other, there was enough in that to see, the jawline were almost perfect.
Right.
Right? But the nose was a little bit off.
What was up with the nose?
Well, when you align the jaw, the nose is shifted slightly. So that means that the camera's angle was not quite perfect.
This was the camera.
With the camera.
Because it was handheld. You didn't have that.
I was handheld. So that was when I talked to Judd, my boss at work, and I said, I need to go back to Egypt.
Yeah. So much better than calling in sick.
Right. And I had actually been there in February and took those photographs, and I was on a tour with John Anthony West as a guest.
Man,
I wasn't co-touring, I wasn't a co-presenter or anything like that. But I thought, well, maybe I need to learn a little bit more about Schwaller de Lubeck, because he was a specialist on Schwaller. I went in with my camera and started to take photographs, and took photographs of the Ramses statue. And I had the photographs on my computer. And when Judd says, well, why do you need to go back to Egypt? And I said, well, I'd better show you. It's better that I show you than tell you.
It's the doctor's note. Right.
So
from Ramses himself.
I'll come back tomorrow with my laptop, and I'll show you why I want to go back. And so I brought my laptop in, and I showed him how I had imported it into my graphic programs, the photograph, and copying it, flipping it, making it transparency out, and then sliding it across so that the jawline matched. And I said, do you see the nose? And
he noticed it.
The nose was skewed. Right. I didn't have that shot quite perfect.
Right.
And I said, I need to go back for a better shot.
Yeah, I got to go back. I got to get it front and center. I need a tripod. I need a laser.
Right.
Yeah.
I need to get. I need a tripod.
Well, so what did he say? Was he like, not only yes, but pack me a bag?
He said, oh, I see. Yeah, okay, I understand now.
Right.
And then the next day he comes to my office. He says, hey, are you going back alone?
Right.
You're not going to be with anybody? And I said, Yeah, I'm going alone.
He realized that you might be the first to realize something that no one has known. Because whenever people see the face of Ramses, they're enthralled with awe. And
Right.
that's about where it stops.
Right.
And you even say in the book, you say the statue is demanding of the viewers. So
Right.
don't just shake your head in awe and then walk away. You're like, it's speaking to us. It's saying this is a map of the universe. This is reality encoded into stone, the best, most familiar way that we would notice it, a face.
Yeah, it's amazing.
And
it's an amazing piece.
it's almost demanding to be replicated,
Right.
you know?
But I realized that I needed to treat it like I was doing a mechanical inspection
Right.
in a shop, right? Except I don't. It's not in a shop.
Right.
It's laid out in the open.
Right.
And you've got guards, circling around you.
Just getting away, these damn guards.
Well, sometimes they're very accommodating and friendly. Other times they can be very aggressive,
Depending on tips.
But even so, it's not ideal for doing very, very close work.
Right.
So,
And you got the sunlight too, and that's coming from different angles.
well, there's
so
that too, yeah.
Right.
And so, the early evening was the best time to photograph, and when the sun was going down, we had an even light. I was staging my camera and just taking a shot here, moving it slightly, take a shot there.
Right. To make
Moving
sure
it slightly, taking a shot there.
This was just to get center.
Right.
And then you realize later, you put them all together, and that's very...
And then I went back to my hotel room and then got the laptop and loaded the photographs in the laptop and did the analysis on it. I was like, damn, I still don't have that perfect shot.
Oh my God. That's got to be aggravating.
So went back the next day and I just did, I don't know what you call it, in sports mode. Mm-hmm. I had a Canon Rebel XT, 8 megapixel.
Yeah.
And so I put it in sports mode. That's where they shoot off rapid fire.
Oh, I see. Yeah.
And so I just penned. Hello.
Sorry. Again, welcome to my living room. This is Dr. Pickles.
Hello, Dr. Pickle.
Just showing you a good side.
Yeah, all right. So you got the sports mode that's going to have, so you can move the camera while it's taking practically video.
And I did it. I had the camera in my hand, right? And there was just one that was the closest.
Yeah.
Is the one that I used in my book.
Right.
But it was still just slightly off.
So it being slightly off, was that the nose again, considering it's the closest? Right. So the nose...
So you're talking about precision, right? Mm-hmm. So if you align the jawline, so you could have the jawline, and say your z-axis is centered over the center of this rotette, mm-hmm. and the jawline is dead center of that rotation.
Got it.
So if you rotate it just a little bit,
right,
maybe 5 thousandths, it makes a difference.
Yeah.
Right?
Yeah.
And so the nose will shift.
Right.
But this will stay pretty much where it is. You won't see any movement at all, hardly, with that thing. Look at a photograph of Ramses' head, and the match, you may be able to detect maybe 10 thousandths of an inch difference. Or
is that in the photograph?
I had some sketches that I demonstrated that in the book.
Yeah.
Right.
So right here is, if you were to look close enough on a computer, you might see a very slight variation.
A slight variation, yeah. All right. But even if you got a 10,000 mismatch at the nose,
right,
all you have to do is rotate it 5,000 and you equal everything out.
Oh, gotcha. Right.
You get it?
Yeah.
So that's the whole story behind this guy, because when Ancient Aliens came to interview me, I thought, I would give my spiel about how we manufacture that kind of precision today. If we were going to create a head, we won't program the whole thing.
Right.
We would just do half of it and then mirror it.
Yeah.
And then run your tool path around it and everything. So,
And then, so today it would have been done, you do one half, and then you copy and paste the other half.
right.
And then that forms into like a kind of a mold or a kind of
Right. So, yeah.
schematic.
Yeah, if you've got symmetry, a symmetrical cavity, or a die or a punch or something like that,
Right.
you'd only need to program half, and then you would copy and mirror that and match it up on the other side.
This is not something we typically attribute to ancient people. That is something that we as a species have come up with recently for like designing cars and stuff.
Well, computers, CAD/CAM, CNC, all of these new technologies that have been evolving since the 70s have made all this possible. When you go back a few years, you go back to the 70s, right, and you look at the fit and finish on an automobile.
Yeah.
The doors, you got maybe, a quarter-inch gap or something
Right.
like that. And then compare it to a automobile that's created today.
Yeah.
And there's a world of difference between the two.
That, I think, makes ancient technology that much more feasible, considering that between 1970 and today, happened quick. I mean,
Yeah.
we came up pretty quick with technology. To think that hasn't happened before is almost ridiculous. But let's say, hypothetically speaking, ancient Egyptian people didn't have computers, all right? They didn't have lasers, right? Which we don't know, but that seems really far-fetched, even to me. How would they have done that symmetry where it's one half a carbon copy on the other half, and then get it to where even when you rotate the camera around it, that symmetry stays? Not to mention, all of that symmetry is sitting on top of a 40-foot granite statue. So where now it wasn't spinning on a lathe. I mean, well,
No.
you might assume it wasn't spinning on a lathe, but how would that have been done with copper chisels and string? Or no way?
There are two things that you have to consider here. One is the tools that you have available to you. The other thing is that it's a matter of consciousness, and it is the consciousness of precision and how important it is.
Right.
Right, and so just having the concept of something needing to be so precise didn't exist in that time.
Okay. There's a reason for it. Wasn't just to look pretty. It wasn't aesthetic. The facial features of Ramses needed to be a representation of something bigger, of something, dare I say, spiritual.
Well, it's definitely a power symbol for sure.
Yeah.
I mean, you get into the Ramses Hall at Luxor, and it's a very impressive place.
Right.
And the seated statues are massive, and they're very well engineered, because they're engineered for strength. They have the headdress that comes down to the shoulder. It's like a gusset, so it strengthens the neck there, and then the false beard that comes down to the chest is like a gusset too, and strengthens the neck here.
Durability engineering.
Right.
They're playing the long game.
And then the other one of the seated statues is they're seated on their throne.
Yeah.
And their hands are rested on their knees.
Right.
Right. And any normal person, if you look at them, their elbows do not reach their thighs.
Right.
Unless you're hunched over like that, right? But if you're sitting normally, your elbows there's a gap between your elbow and your thigh.
Yeah.
But they had modified their statues so that there was no break.
Right.
Right.
It's just as
the elbows were firmly attached to their thighs.
One solid piece.
One
that doesn't
solid piece.
really have a lot of weak spots.
Yeah.
Except for that damn nose that is always chipped off of a lot of them. But
Yeah, well, I think that is because, from what I heard, it was the statue had power, and they were seen to be gods, right? And
Yeah.
so, and the nose is symbolic of breathing.
okay,
And so to
snuffing out.
kill the statue, they chop off the nose so it can't breathe. You know, when I look at the Ramses statue, it seems like it is, if you did a survey, you took a photograph of everybody's nose and took the average of every one of them,
Okay.
then you come up with this kind of idealized image.
Because these statues are not meant to be anatomically human. They're meant to represent perfect geometric mathematics.
Right.
This is almost a display of the reality code of like phi ratio, the golden section, Fibonacci sequence. It's almost like they weren't trying to represent Ramses as a person.
Right.
It's almost like these statues are representing that by which Ramses' power can exist. You know, this code or matrix, dare I say, that forms these rules of reality. It's like they tapped into that, and they were able to extrapolate that into artwork, which just so happens to appear to be very powerful. You know?
Yeah, if indeed they do represent Ramses, because there is different qualities of carving on those statues.
Yeah.
You'd see very, very deeply incised sunken reliefs with three-dimensional profiling at the bottom.
Right.
And very, very accurate. And then you have scratches. Somebody came along and, just personalized it.
Personalized the thing.
So I'm not an Egyptologist. I don't know how they attributed those statues to Ramses.
Right.
But having looked at the mummy of Ramses in the Luxor Museum, taken a photograph of it, the proportions on the Ramses mummy compared to the Ramses statues, they just don't fit.
Really?
Right.
I had no idea about that. So it's not entirely clear why they attributed this statue or series of statues to Ramses. This is kind of an assumption almost.
Well, I mean, it's not entirely clear to me. I'm sure that there are some people out there who are very convinced. Sometimes
they will find the name of a pharaoh etched into, say, not the Serapeum, but the water temple, Osirion, where the Osirion, that type of stonework is indicative of the original pyramids. These kind of like large blocks, there's no curvature. It's just very stark, geometric. It almost seems like it's there for a reason. The Osirion seems like a battery that you would, because that's how it's laid out, like a battery. But some pharaoh at some point wrote his name. And the Egyptologists seem to run with that. And say, well, this is 4th dynasty. Whereas, geologists might come through and say, this is older. How do you feel about this evolution of change throughout the stonework of Egypt? Because would I be incorrect in saying that the work gets worse over time?
I'm not so sure about that.
Okay.
And really, I mean, we can speculate and comment, but I think, I'm at the point now where I will talk about the engineering and, just the data, the facts, and things like that. But I think the Egyptians, if their history is going to be rewritten, then it's the Egyptians that need to write it. So those are all very good questions. And perhaps they will, in time, find answers to them. That are a little, more solid than what we have now.
Well, it's a difficult question because you can't carbon date it. And even if you could carbon date it, You carbon date one thing in two different labs, you've got 1,000-year differences, you know.
Right.
So even carbon dating itself is a little loose, but it's like from an outside point of view, and it is entirely up to the Egyptians as to how their history is represented, and it should be not only correct but to the heart of Egyptians, you know.
Right.
But I find it to be so strange when I see the Osirion and the pyramids or the schist disk, and these things are not meant to be beautiful or artsy. They are meant to have a purpose, some kind of function, a utility. And then adjacent to that, almost completely opposite, even though it's made of the same stone, well, not all of them, but you have these Ramses statues and Nefertari, which are a lot of curvature. It almost seems like left brain, right brained, if you think about it, right?
Right.
So when you see the pyramids, you say that's left brain. When you see Nefertari or Ramses, that's igniting your right brain. And there's
But there's a lot of left brain in that.
yeah, to get to that point, right? So like you said, Ramses wakes up both sides of your hemisphere, creativity-wise and like how did this come to be, you know?
Right.
Whereas I think some of the oldest stuff are square, if I might use the slang term. They're kind of square, you know?
Right, yeah.
But that's not too different from us because we have things that are meant to be just utility, like the inside of a car engine. And we have things that are meant to be beautiful, like the outside of the car. So in a way, that might not be so mysterious because they're just like us in that regard, you know?
Yeah.
We become comfortable to the extent that we can master our environment, but eventually we all must yield to the ultimate power, which is time, I guess. And that makes us uncomfortable, I think.
Yes, you know, I think that a lot of people don't really want to hear about it. They don't want to feel that, you know, that they are they're living by the grace, so to speak, because it's kind of like, you know, it could all turn to shit tomorrow.
Right.
And but the reality is that it can all turn to shit tomorrow.
It's a scary thought to think the Egyptian civilization was in function for 7,000 years, debatably. Meanwhile, we've been here since, I mean, what year is it? 2025. There's a shift in perspective there where you say, we are babies compared to the Egyptian civilization. And to realize that that came to an end when they were, I mean, killing it. They were absolutely the peak. Heaven on earth is what it was called. They wanted to replicate heaven on earth, which is why this geometry is so perfect.
Yeah.
And to realize that can go away, whether it be an environmental disaster or a conquering by Alexander the Great or whatever, you know, that things are temporary. And
speaking of how long a civilization lasts, the Egyptian civilization is supposed to have lasted 3,000 years.
Right.
And our civilization is what?
Whatever year it is now, I don't know if we're
500. I mean, you know, modern civilization.
Right.
Since the Industrial Revolution. You go back to the ancient Egyptians and the tools and methods that they were using to create their artifacts at the beginning of their civilization. The same tools that they were using at the end. So that is where, you know, for maybe, you know, you could accuse me of having a modern mindset, but I think it's a human mindset, really.
Yeah.
We're always trying to make things a little easier.
Right. That's what innovation does. It's meant to make.
Right, to innovate.
Right.
But to say that the ancient Egyptians did not develop their tools to
progressively
any significant degree over a 3,000-year period.
Right.
That's a little hard to swallow.
It doesn't make any sense. There's just no way.
Doesn't make sense.
Right.
It's not human nature.
Right.
Oh, by the way,
oh my goodness.
I brought you some pencils.
You know what? I don't know.
I want you to do a spiel. Just do your whole spiel about that.
Well, when it comes to the Dixon Ticonderoga HB Soft #2 pencil, you can ensure that this is not only the kindest gift I can think of, but this tells me that you watched the full episode, and that fills my heart with joy that you got to this point in the video and you were like, all right, let's bring this guy some pencils. This is a 6-pack of pencils right here.
Is it?
There's 6 packs in there. Do you want one? Anthony? Yeah? Pack of pencils?
Pack of pencils.
Absolutely. I don't know. Hey, as long as we're talking about being a tradesman and being a machinist here, no joke. When you sharpen a pencil and the lead is kicked off to one side in the pencil and then you've got that weird little angle on the wood, I'm done with that. Ticonderoga, however, you ain't gonna have it. He's centered lead. Here, Anthony, have yourself.
Thank you, sir.
Have Chris sign it at the end. Right. All right. Well,
Okay, is your commercial done now?
I think my commercial's done now. So I wanted to talk a bit about, let's see, what was in here that I had? Okay, forced perspective, the lips of Ramses.
Oh, yeah.
What was going through your mind? So the first thing that you saw was that the lips are not quite human. They're not natural, right?
Right.
Now, immediately this is going to make ancient astronaut theories. People start to whatever. But you saw it as a machinist and as a way of perspective, like the Parthenon, like they did in Greece, right?
Right.
So the smile of Ramses is curled up on the edges
Right.
for a reason.
Yeah, it's like if you actually draw an outline around the face, the features of the face, and then you take the statue or the photograph of him to the side, it looks like a cartoon character.
Yeah.
Right.
Right.
And the smile is like you said, it's like you're looking at the Joker.
Looks like the Joker. Right.
And but then there was a one presentation I did. I took some golf balls. You got any golf balls? No golf balls, ping pong balls.
Okay.
Anyway, so you get a ping pong ball, right? And then you draw a straight line.
Okay. Yeah.
Across it, right? And then you tilt it that way, and you'll see it go down.
Yeah.
Smile, right?
Yeah.
It's that kind of thing. Well, the head that I was photographing was at eye level.
Right.
It's on the ground, right? It's on a plinth right by the obelisk outside the Luxor temple.
Okay.
And and so photographing that and looking at the shape of the mouth and even the eyes have that kind of look to them where they are looking down.
Yes.
But you have to say, okay, this head was at one time like 20 feet up in the air.
Right.
So, the people that came into the temple were looking up at Ramses' face.
Yeah.
If it had been carved like a normal mouth,
Right.
Ramses would have looked a little more severe, looking down at the.
It's already got that power. You don't want it to be frowning.
Right.
It's the last thing you want to see.
Right. So it kind of keeps him to like a friendly fellow
Right.
to look at.
Meanwhile, the statues that were meant to be eye level don't have that curvature. They don't have that little snarl in the lip at the end.
Right. So all of those are kind of visual compensations to.
That blows my mind that in the history books, Egyptian civilization seemed to, what they say, come directly from hunter-gatherers. Like one day, hunter-gatherers were like, you know what? Let's build pyramids and statues, right?
Yeah.
But then the deeper you look into it with the symmetry and then forced perspective, this is a deeply thought out mechanism for the mouth to be smiling at that height, no matter what angle you're looking at it at. It doesn't matter. They did a forced perspective. This is something that we do today in art in various different ways. To think that a civilization jump-started immediately to having the forethought a forced perspective is something that my brain refuses to even accept. It makes me think either the Egyptian civilization went back way longer than we are considering. Yeah. Well, I mean, what are the prototypes that lead up to Egypt?
Right, exactly. I
can't think of any.
Yeah, that's a really good thought, because it's almost like it just appeared.
Right. And then you were saying that the tops of the eyes are protruded out just a little bit for the statue.
Well, if you look at the side, if you look at the profile of the statue, the eyes are looking down.
Right. Even without pupil and retina.
Right.
It gives the impression of looking down.
So, yeah, the statue, the god, is gazing down, smiling.
Right.
At the supplicants entering into the temple.
Okay, so you had talked about in Lost Technologies a little bit about the process of making anything. You have a design team, and then you have the actual builders. Are we looking at something similar to that with Ramses or anything in Egypt? Do you think that there was a team who designed these things? Or do you think that all of the builders were just as brilliant?
Well, they seem to have a standard model, because every face of Ramses looks exactly the same.
Is that so?
Right.
Okay.
There's no mistaking the Ramses face. Whether you're looking at...
It don't look like Akhenaten. Right. It don't look like Akhenaten. Right.
No, they don't look like Akhenaten.
Right.
They look like Ramses. But the accuracy and the precision on all of them is identical.
Right.
So, within certain limits. You know, one of the things when you talk about manufacturing, you talk about manufacturing processes, there's always mistakes, there's always slip-ups and stuff like that. And you'll find that in the statues. Mm-hmm. Like the one that they took from the Ramesseum and took to England, it's now in the British Museum. Okay. You can see where they had compensated for a mistake in the corner of the mouth when they were cutting the corner of the mouth. Right. And so they had recut the lips and pushed them further back. That increased the cut. There's now a cusp.
Yeah, it's almost got a sharp lip on
right at the vermilion border. Around there. Yeah.
So that was what you're thinking is they're chipping away at the stone, however which way they're doing it. They went a little bit too deep in the corner of the mouth, so instead of having a dimple, they shaved off around the lips in such a way to make it not a mistake anymore. But then you have the lip.
But you still have a trace of that ding or that area where they went too deep into the material.
So that's a tool mark.
Yeah.
What does that tell you as a machinist? What kind of tool was being used for that? I mean, can you tell?
There is a telltale mark on the lip, the upper lip of the statue at Luxor. And it looks like they were using a square bit. Okay. It had, just like a square end. And it was probably maybe 3/8 of an inch or something like that. But it was kind of square or rectangular.
Yeah. But that tells us there's various different kinds of bits being used.
Right.
When we look at a table, let's say, Hawas's book, which he won't release the photographs, so you got to buy the book. He said, here's all the tools, right? And they're basically, every one of them is a chisel. You got a hammer and a chisel. But that doesn't pan out when you look at the cheek and you look at the Fibonacci sequence, when you look at the eyes. And when you look at the lip, you're seeing a tool mark that indicates that whatever made the cheeks and the eyes was a different tool than what was doing the lip.
Well, yeah, you would have different tools.
Yeah.
Different. You have roughing tools, and then semi-finished tools, and then finishing tools.
Let's talk about the finished tools, because I think everyone can kind of wrap their mind around the rough tools, right? You get a prototype going, you have the design or whatever. However, the finishing tools, you said you run your hand across the crown, so to speak, whichever, and it's completely smooth, right? There's no divots in it. If you have to make something smooth, back when I used to manufacture glass, we have a polished edge for offices, basically. An office door is made of all glass or whatever. It's got that polished edge, so it's shiny and transparent. If we polish it too much, it changes the size of the glass. Now you've got a gap. What's going on here with you got the perfection of the symmetry of the cheeks, the eyes, everything's symmetrical, but that had to be polished and finished to such a degree that if something was done wrong, you got to do it to the other side now. Like, what are we looking at when it comes to the finishing tools?
You would want to use the most robust, largest tool possible.
Okay.
Where possible.
Yeah.
And so the tool that they would use to do the general face, right? So you basically, you would cut all of this. If you were doing it in a CNC with a larger tool, you would come down here, all of this would be kind of left alone.
Okay.
With the larger tool, even the mouth, the lips would be left alone.
Okay.
So that larger tool would create all of this except the finer detail.
Okay.
Like the nostrils and things like that.
Yeah.
And so you're done with that tool, then you have to come in with a smaller tool to cut all the finer details, maybe even two. And then, the final tool where you find your divot in the mouth, that would be a fairly small tool. The interesting thing about that small tool on the lips at Luxor, it's pretty much the same size as the divots in the Ramses statue at Karnak.
Okay. All right.
Okay, so you'll show that photograph of the one at Karnak.
Yeah.
Where you see these divots right above the eyebrow. And it's almost like stitch marks, but you can see that they're divots. Another aspect to that is, okay, so if they are machining this face, and they're coming to the eyebrows, and then they're changing direction or something.
I'm sorry, guys. All right. We'll cut it. Paul comes and goes as he pleases, right? He's a hunter. He likes to stay outside, right? So I get up in the morning, I feed Dr. Pickles. He says, thank you, I'm a gentleman. He goes off to invade Poland. And then Paul comes home and he's like, hey, I'm here now, I'm ready to eat. He's a damn teenager. He's out there partying, killing rabbits, getting all the attention. He's a rock star. He comes back home, he's like, I'm ready for food now. Stop what you're doing. Who's that, Chris Dunn? I don't care. Put some wet food in my bowl, I won't eat dry. I'm like, all right, And we're coming down, we get to the ridge of the eyebrow.
Well, yeah, and this is where a condition was left there that is normal when you are taking a cut with a tool.
Yeah.
Okay, and depending on how the tool is powered, these divots above the eyebrow of the Ramses at Karnak seem to indicate that there's a rectangular tool, passes were being made, it paused, and because the tool was energized with vibration, whether it's sonic, ultrasonic, or whatever,
right.
When the tool paused, the tool was still alive, right? So it's cutting normally, or it's pounding away, chipping away normally, but the movement of the axes is creating a smooth surface until it pauses, and then that pounding continues until it moves again. But what happens is it leaves a divot right at the top of the eyebrow. This
can only happen with a machine that is powered, because you said pauses. When the machine pauses, this is like if you've got a jigsaw and you want to get it to full speed before you touch the material with the jigsaw. Because if you put it up against the material and then turn it on, you clack, 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 But you bring the jigsaw to full speed and then you approach the substance that you're cutting, right? Wood or anything like that, and then you get that smooth cut. Whereas if you were to pause that blade for even just a moment, it yanks on the whatever it is, it grabs it.
Yeah.
And that's what we're looking at here.
It's the same with if you're on a milling machine and you have a milling cutter.
Yeah.
And you're cutting the top face of a piece of material, piece of steel.
Right.
And you would normally just allow that tool to just go right across without pausing. If you pause it, like in the center of it, before continuing on, it will leave a ghost mark right where you paused it.
This wouldn't be different than a can of spray paint. You keep it in motion and you get it in motion,
right?
But if you pause for a moment, it's gonna you're gonna get that blotch right there, and that's what I'm looking at right here. That is something else because this is proof of machines. That what you're describing couldn't be done with a chisel because it would have had to been done on purpose in that case.
Why would you do that on purpose?
Right.
Exactly.
So, I mean, we're talking about electricity.
I just take that for granted.
Right. That's almost assumed.
Sorry, I wrote the Giza power plant before.
That's all. We're already right. You're like, we're past that point here.
Yeah.
That makes two mysteries solve each other. Because what did the pyramid do? What was its function? And then how did they machine, or what tools did they use to create these beautiful statues? That brings together two things. The question I had I've been poring over is why are some Egyptian relics very left brain? The pyramid, Osirian, they're not decorative. They're not meant to be seen, but they're exactly precise. But over here we have these beautiful phi ratio, gentle curvatures, Nefertari. It's right-brained. They were using the power plant, the Osirian, as a form of utility to make art.
Well, they knew how to harness electricity. Whatever means that they used doesn't mean that power came from the Great Pyramid, but it's kind of like there's what came first, the chicken or the egg kind of scenario, right? Because
then what tools were used to actually create the pyramid and Osirian?
Yeah.
What do you think of that anyway? What would you speculate as far as, because when they had the pyramid, they had the power needed to do the rest of these things, supposedly.
Well, I mean, the whole scenario is that they had the wireless distribution of electricity. So whatever means that they had to collect it, within a particular field or area.
Right.
It's just like you go onto a building site, you don't necessarily always run a power cord from a nuclear power plant.
Right.
You take a generator on site. Right. Right?
Yeah.
So, the whole idea of, well, there's only one power plant in Egypt, and that's the pyramids.
Not necessarily.
No, not necessarily. That's a very, very advanced way of harnessing electricity.
Right.
But it doesn't mean that they didn't have other ways to do it, just like we do.
Again, just like we do, we might not be so different. The more I delve into this, the more human it becomes. Ironically, they're probably just like us. We're on the job site and effing and blinding and cussing up a storm. Right.
Yeah. Who knows?
Not so different after all.
Go home and drink their six-pack.
Right. Which they had beer. We know that.
Well, So they had beer. Yeah.
When we look at an ancient civilization that was as advanced, if not more, than us, it creates so much speculation that people romanticize these extreme, complicated scenarios. Whereas the truth of the matter might be not only more fascinating, but something a little bit more down to earth than we were expecting.
Right.
But the implications of such are enormous. It tells us that not only are we more powerful ourselves than we could have ever imagined or that we're told, but civilizations come and go.
there has been a huge interest from tradespeople,
Yeah.
machinists, engineers, tool makers, and when you look at how many Egyptologists there are in America and how many tradespeople there are,
Yeah.
you have like 8.5 million tradespeople,
Right.
and 300 Egyptologists.
Yep.
But when I started writing or discussing things on the on message boards on the internet, there weren't any tool makers and machinists. I didn't know any machinist back then that had a computer.
Really?
Oh, yeah. I don't think Facebook existed back then.
Right.
When did Facebook come in?
Ah, shoot, I think 2005, something like that.
Was it 2005?
I'm not positive.
Yeah. So, and I stopped discussing it on message boards in 2003 because I went from like 1995 to 2003.
Right.
Being called, you're just a lone voice in the wilderness. Nobody's listening to you.
That's what the internet's for. Yeah.
And now millions of people are listening.
Oh, some of my favorite comments have been on the Pyramid Power Plant video that's dedicated to your work. There are machinists, tradesmen, they are in the comments saying that not only thank you for bringing this to light, but some of them didn't realize. They had no idea.
Right.
So, I mean, they'll watch a documentary about the pyramids on PBS or whatever when they were a kid, and that's what they're kind of running with their whole life. It's just in the back of their mind. And then they see something like that, and they go, this is recognizable. This is something that we are familiar with, and this is something that is a utility that, I mean, no one gave it a second look because the Egyptologists kind of took over. And as you had made clear in your book, the foundation of Egyptology, we didn't have machines. Society didn't have machines.
Right. Well, I don't want to keep beating up on Egyptologists or archaeologists, but the thing is that they are doing what we expected them to do.
Yeah.
We said, okay, it's your job to research our past and teach our kids what existed back then, and the archaeologists will do the digging, and the historians will write their books, and so on and so forth. But we expect too much from them.
Yeah.
Because how can you go through high school into university, you graduate with a PhD, you stay in a university setting, and you totally bypass those 8.5 million tradespeople. You don't even have any visibility into the nuts and bolts of society.
Right.
Whereas those who are, cranking handles and turning spanners are basically what keeps everything going.
Yes. They keep society rolling.
They keep society going.
And these are the guys who take a look at these things and are familiar.
Right.
And you're right. It is easy to beat up on Egyptologists talking smack and stuff like that because they seem like gatekeepers. But the fact of the matter is that when they were theorizing, machines didn't exist. They had nothing to compare the pyramid to. Right. They didn't have a reference point, so they were working with what they had the best.
Yeah, but they draw off public money, and the public money is like, this is what we expect you to do your job, and blah, blah, blah. And then suddenly somebody comes along and says, hey, wait a minute, you've missed something.
Yeah.
And how they react to that, I think, is not to their credit, really. I mean, the way they're behaving.
Okay.
In reaction to it.
Whenever something is in need of an update, it's in need of an update.
Right.
We need to be comfortable with change. And that is, I think, so not saying that Egyptologists are gatekeepers, but damn it, when new information is presented, new hypotheses need to come to light and be embraced.
Right.
I mean, we've seen this before with, Bruno, Copernicus, Galileo. I mean, these things where there's a lot of pushback or whatever, but at the end of the day, somebody's got to put all the information together and say, I think we go around the sun. There's something. So we're looking at this today, and what I find to be fascinating is that my son, who's 13 right now, is going to be growing up in a world where the tomb theory is gone. That'll be the conspiracy,
Right. And it's picked up so quickly.
Yeah.
It's really taken me by surprise, because I was ready to, head to the exit, and was like, okay, somebody else can pick it up. Maybe the next generation will get it figured out, but, I've done my job, and that's it. But now it's like, oh, wait a minute.
Yeah. When I see guys picking up Ben from,
Uncharted X.
Uncharted X.
Yeah.
So he is really honed in on those vases. It's great to see that become a successful endeavor, because now people are interested in this. The torch is being passed. And rest assured, by the way, people like myself and Ben are going to keep this torch going. And hopefully the idea is to keep it grounded as you have.
Yeah.
In a realm of fact, to make it clear when we're speculating, as opposed to saying definitively that we know where things are coming from. That way that torch gets passed in a pure manner.
Well, before you get off the subject of the vases, it was actually my son Alex that spearheaded that.
Really?
Yeah.
Okay.
He was the originator of the idea. He met the owner of the what they call the OG.
The OG.
The OG vase, yeah. It was Adam Young, who had this collection of pre-dynastic vases.
Right.
And they and it was on a tour in Egypt that I was leading.
Yeah.
A lost technology tour. I talk about it in the Giza power plant. Even proposing a method where they could hollow out the insides, but it was a method of machining that I'm familiar with, which is what they call chamber boring.
Okay, the way of scooping it out with that L angle.
Scooping it out, right.
Gotcha.
He brought the vase in, they set it up in the inspection lab.
Yeah.
To check concentricity and other features on it. Then in Adam, I had it scanned at Capture 3D. And got the scan data. Alex worked with an engineer at Rolls-Royce to import the scan data.
That came in handy.
And create an STL file.
Right.
And so that STL file was sitting out there for a while, and then Adam and Alex decided that, well, we need to do something with this.
Yeah.
Right, and Alex suggested taking it to Ben because he seemed to be a good guy to be able to share that information. He had a wide audience.
Right.
And so that's the story behind that.
The sequence of events there is almost synchronicities, that he worked on the military base.
Right.
He had.
And I have to confess, I was really skeptical about where it would go, because my idea was that you would follow a conventional path.
Okay.
You would write articles, have them published, and blah blah blah. And Alex said, "No, we need to blast it out into the world," and we did. Yeah. And then it was like it took fire.
Are you still on board with this? Is this still in your mind as the way that they scooped out these?
A variance of that.
A variance of this?
Yeah.
What would you update about this?
What would I update?
Yeah.
Well, for one thing, the vases have handles on them, so that would involve some additional machining methods.
These handles on. So, are we talking about a lathe when it comes to these vases, or do those handles?
I'd say principally yes, because the geometry of the handles would be cut 360 degrees. So you basically cut the basic shape. Okay. Right? And even the handles All right.
Okay.
It wouldn't be a handle. It would be like a donut or a torus around
all the
it.
way around.
Right. So
Yeah.
it's all the way around it.
Okay.
And then you'd have to come in with a different machine, different tool,
Okay.
and clear out between that, define the handles and clear out between, matching the same contour.
Which this raises questions about symmetry, because if you're using a lathe and this is spinning, well, first of all, this is ignoring the fact that some of them are granite, some of them are schist.
Right.
It's a hard material.
The granite, diorite,
Right.
basalt.
So we're kind of putting that notion aside for now and saying that you've got this spinning object. No matter what you do to this side is going to happen to this side because it's spinning, right? So you leave a donut shape around the vase where you know your handle's going to be.
Right.
Now, once that is done, you have to now by hand chip away everywhere where that handle is not.
Not by hand. You need a machine to hold the accuracy.
Okay.
Yeah.
So, I mean, are there tool marks to represent where they removed material, where the handles around the perimeter where those handles are?
Well, what you do see at the corners of the handles are the radius of the tool.
Okay.
And the other interesting thing is that, and I've got a photograph of it, I'll send you,
Sure.
but right under the lip, the top lip of the vase, you can see where they had used a larger tool to do the cutting, and then they took a tool with a smaller radius. I'm saying a tool, it could be a grinder, it could be, whatever tool they had. It had a smaller radius, and then they cut the detail under the lip.
Okay.
With a very small radius there.
Yeah.
And you can see the definition between the two. You can see.
Really?
Yeah.
Okay. Right. I would love to see that photo.
I'll send it to you.
These mineral stones that cannot be liquid. I mean, we're assuming. So whenever you have a chunk of granite or schist spinning on a lathe, what are we applying to this chunk of stone that's not going to send it flying whenever it's spinning at that high speed? I mean,
well,
that's all right.
I mean, that is a fundamental question on any machining. It's like you can apply a tool to a piece and put enough pressure on it that you could break it free from its mooring, so to speak. If it's chucked up in a 3-jaw, 4-jaw chuck, then you have to be careful. You can't exceed the limitations of your machine.
Right.
What kind of tool they used? I mean, I would select a grinding wheel.
Okay.
And to cut the outside, and then sections of a grinding wheel attached to a post to hook in on the inside, and then you would use the rotation of the piece of the lathe. That would be your cutting force, right?
Yeah.
And then basically you cut the material according to the specifications of the manufacturer of your diamond wheel or your diamond segment, because you don't want to crowd it, you don't want to put too much pressure on it, and obviously you have to cool it because heat is the biggest enemy of tools.
Is there any marks showing how they anchored the vase or whatever these symmetrical items to the lathe? Because
no, I don't think when they made them, what they were holding on to doesn't exist anymore.
Okay.
They would have taken a piece that was maybe 2-3 inches longer than the overall length, and then they would cut it off or part it off after they finished everything.
Yeah. So the lathe is now missing. They would have sanded that off. But I can't imagine, because these vases, I'm going to pronounce it different every time. These vases are round at the bottom sometimes, and there's no hole going through.
Right.
So it would have had to either be extremely heavy duty or attached in such a way to the lathe from the outside, maybe like some kind of clamps around the outside that was later shaved off.
Right. Well, those spinners, they call them, because they are, they're perfectly round at the bottom,
right,
and balanced. You would have it attached to a piece. It would be part of the natural rock, right? Mm-hmm. And then you would part it off, and then perhaps turn that bowl around,
okay,
and chuck it up on the inside bore or around the ring, and then machine the bottom of it.
It's almost like you'd have to get in there from the bottom to scoop it out, like.
Right.
My head is spinning right now because
You're like a lathe.
Yeah, because some of these
You're
things.
a lazy fellow, huh?
I'm very lazy. Don't tell my bosses that. You're retired, so you get away with it.
Today, most modern machinists only know CNC, so they automatically say, "Oh, you need a CNC machine to do that." But in the 50s, 60s, they had what you call true trace equipment, hydraulic tracing equipment, and a machine called Kellers. These are three-dimensional profiling equipment. So I was familiar with those because I'm older than dirt, right?
Sure, all right.
And
that's why we're carrying the torch on. Go ahead.
But my son Alex had never heard of a Keller.
I see.
Or a true trace.
Yeah.
They had left the shop.
That's how quickly our technology is replaced with new technology.
Right.
It happens so fast that you came up in a world where you're able to put A and B together, whereas this generation today might not have ever made that connection. The coordinate system, you talked about it several times, but mostly with the boxes at Saqqara, a Cartesian coordinate system, right? This is what I think put me into overdrive the most whenever reading Tesla Connection, was the boxes are perfect in a place where your eyes are not going to see them, which we've covered, but the bottom of the boxes are left rough. They say that they were coffins for bulls, that's probably the weirdest explanation I could have thought of. I don't see that happening. But basically, there's no reason for the inside of these boxes to be so absolutely flat, whereas the bottoms are left rough. Right. You bring up a Cartesian coordinate system. What's going through your mind with that? What would have been the purpose? Because you mentioned maybe growing crystals. Before you even said this in your book, you said, let's take a walk on the wild side.
I did.
Like, that's what you got to say first. But what's going through your mind with this, the Cartesian coordinate systems?
Just about everything about those boxes is kind of mysterious, right?
Yeah. Right.
And to make one of those today would be enormously expensive. Enormously expensive. So
you had numbers ran.
Yes, yeah. And I didn't really get a firm number because they said they won't be able to create one.
Yeah.
They would make a box, make it out of 5 pieces.
Slabs.
And then, then ship it to the job site.
Wow.
But as far as hollowing out a single block of granite or basalt and creating the box.
See, you're not saying it's impossible.
Doesn't mean that it can't be done.
Right. But we ain't.
But it's going to cost. It's going to cost a hell of a lot of money.
Yeah.
Going into that chapter, the first question that I needed to address was, where are the machines? Because that has always been a huge question.
Yeah.
We don't have any machines. We don't have any remnants of machines. Things that you could actually relate to. Even though I do describe the Great Pyramid as a machine, but these boxes, how were they made? What kind of machinery would have been used to actually cut them?
In a corner.
Right, and so that's where, having been in manufacturing for 52 years and seeing the way things work where you actually have attachments that they don't take the part to a separate machine, but they have attachments that they fit on the part.
Yeah.
Right, to machine them. I mean, you're talking about these huge rolling mills if they need a rebore, stuff like that.
Right.
They have these separate pieces of equipment that they attach to along the rolling mill and rebore that way. So I had thought that, well, okay, what we have is a surface, the top surface of the box, that would be extremely precise.
Right.
And perhaps they use that surface as a way, okay, or a surface upon which a sliding member could go across, but that sliding member will be controlled like an axis on a machine. And today you do have machines, they call them coordinate measuring machines, and the base is a granite base. It's like an inspection grade or laboratory grade base, and then the superstructure or the bridge will actually ride directly on the granite.
Okay.
And that serves as what we call a way.
Right.
For the
that
machine.
Initial slab of granite has to be completely flat because you're going off of the...
Right. And so if you attached like a bridge to the top of the box after the top surface has been finished flat, you have the top of the box serving as an x-axis, and then the bridge itself is the y-axis, and then you have a z-axis. That z-axis holds the tool or the grinding wheel that will grind the inside.
That's your vertical member at that point.
And so everything is cut to precision using that method.
So that answers the question of the vertical walls. What are we doing at the corners? The bottom corners.
Yeah, the corners are, the devil's in the detail, isn't it, my friend?
It drives me crazy.
Have you ever been to Egypt?
No, I have not.
Well, if you don't want to,
not yet.
If you don't want to go absolutely bonkers, stay away.
Yeah, right.
The way you're reacting, just talking about it, it's like, you'd have a good time.
Yeah.
But the corners are something else.
Right.
You have because what you have is one surface coming into a corner, and there's like a 5/32 radius in the corner.
Okay.
Right.
30 seconds.
Yeah. On some of them, you'll see where there is no cusp. It's like if you bring one, a radial tool on one surface into the corner.
Yeah.
Right?
Yeah.
And then another one. A lot of times you'll find a cusp, but there doesn't seem to be any. And then the flatness of the surface is right up to the tangency point of the radius.
Right. I don't know. Do we have to just be comfortable with these corners being a mystery, or is there,
Well, I think everything's a mystery.
Yeah.
Right. And so, what you have is you have an attempt to explain things. And how do you explain things? You draw on your own background experience, and you start digging into books to research things. There are other features of the boxes that are significant too. The walls are so thick, right? So you have the long part of the box, the walls are maybe 16 inches thick or something, and then on the ends they're about 12 inches.
Okay.
And I'm saying that roughly.
Sure.
Just eyeballing it. Right. There's a difference between the two.
Right.
So somebody can go down in that box and find that it's 17 and 13 and call me a liar. I don't give a shit.
No, but there's a difference in the thickness.
Well, there's a difference in the thickness.
There's a reason.
So that's significant.
Right.
And the other interesting thing, and I have to credit Billy Carson.
Really?
for the question.
Okay, yeah, that's all good. No,
No,
I'll have them on the show.
no. It's kind of like the question is sometimes more important than what answers you come up with.
100%.
Right?
Yeah.
You're not asking the right question, then
Right.
you don't consider what the answers may be. He asked the question. So why are the lids of the boxes so thick?
Okay, right. A lot of weights there.
Right. Nobody had asked me that question before.
Okay.
I don't think I'd asked myself that question before, but he asked it, and I was like, wow, that is an excellent question.
That stirs the mind a bit, yeah.
And so right off the fly, I said, well, that might lead into the need for the underside of the lid, which is precise and flat, that it will be stable, kind of like a bridge, right? And so if you had a thin lid, it may sag in the middle. And so this would avoid that sag, because some of the boxes, they're angled off on the edges.
Okay.
You know, on the sides and the front and back.
It's a very specific shape.
Right.
Yeah.
What everything led to was the most important feature or attribute of these boxes are the insides.
Yeah.
So whatever they were made for, it was happening inside.
Right.
And then we take a walk on the wild side.
Yes. Right.
Right?
That's what I'm all about.
So, you know, and you think about miniaturization and manufacturing. When you look at the interior surfaces of that box, of a box, so you have the lid and the four sides.
Yeah.
You basically have what could serve as a Cartesian coordinate system.
Yeah.
So you have your X, Y, and Z, right? And so you'd be able to plot any point within that Cartesian coordinate system with precision.
Down to a molecular level.
Down to, a couple of 10,000ths of an inch, something like that.
Right. A ridiculous amount of...
Very, 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 very tightly controlled, right.
Enough precision to say that's not that's not artwork. That's got to function.
One of the other features of the installation is that these boxes are set in a recess. Okay, you have a crypt.
Right.
And then the boxes go in the center of the crypt. Mm-hmm. But the center, the floor is not on the same level as the tunnel floor.
Right.
It drops down about 5 feet. You have to drop down quite a bit to get to the floor of the crypt. Now, why would they do that?
Also not artistic.
Right. And then I get all my best ideas from other people. They're not homegrown.
Okay.
So Eric is full of ideas,
sure.
Right? So he's like, well, you know, the other feature is the boxes are set in recesses in the middle of the floor and dropped into these recesses. So they can't shift.
The lids.
So then the question the speculation that, well, perhaps there was vibration or energy involved in whatever process was going on there.
Yeah.
Eric came up with the idea, well, they could have been growing crystals in there.
Okay.
Right?
Which the crystals were a necessary item.
Right.
To the Egyptians, right. Pre-Dynastic especially.
Right.
As a transducer and everything.
The question is, what kind of crystals? Eric is actually living in Egypt now. He and his partner, soon to be married, have a built a facility near Abu Sir. She was in the Serapeum with Eric, and she came up with the idea because she had some knowledge of crystals and crystal growth. But she came up with the idea that the the crypts were actually filled with water, and the water was heated. And so basically they were keeping those boxes at a certain temperature.
Yeah.
If they were able to control the temperature of the water, which I wouldn't put it past them considering they built the pyramids.
Right. Everything else becomes more like, well, of
Right,
course.
yeah.
Right.
And then I remembered a book by Eric Drexler called Engines of Creation,
Okay.
when he was talking about nanotechnology and how universal assemblers
Right.
that would actually build products atom by atom.
Yeah.
So rather than a reductive process where you've taken a huge ingot of iron, or a forging or a casting, and you're removing material to achieve a final shape.
Right.
This is an additive process where things are being built up, but in a very, very sophisticated way, atom by atom.
Like a 3D printer.
Like a 3D printer, but a lot different than a 3D printer.
Okay.
That opened up the idea of, okay, if you have like an environment where you have these nano assemblers and there is a pool of raw materials, say, at the bottom of the box.
Yeah.
And they go down to there, they pick up an atom and they shoot up and place it somewhere. Yeah. How do they know where to place it?
Okay, that's where the Cartesian system comes in.
Right.
You've got the four sides.
You got the four sides on the lid creating the Cartesian system.
Yeah.
So, it's a lot more technical than that.
Sure.
I'm just in a simple way.
Right.
You've got this happy swimmer who, he's dives down, picks up an atom, he's doing his job,
Right.
And he wants to know where to place it. So if you have an active surface, a Cartesian coordinate system with an active surface, so maybe you have some kind of a coding on the inside of them. They can send a signal to receive a signal. They would be able to receive the information where they need to be with that particular atom, to join it to another piece. Now, Eric Drexler, he claims that, a rocket engine, you could grow a rocket engine in a bathtub or whatever and reduce the weight from the way we conventionally make them by 90%. Here you have a potential technology using nanotechnology, micro assemblers, or they call them universal assemblers is what Eric called them. That is building up these engines with precision, and they're coming out fully formed and functional.
Yeah.
But you have the added kind of benefit to, you don't have any rivets, you don't have any welds.
Right.
Everything is a single crystal, strong, and just imagine the research and development and the outcome products that you would arise out of developing material technology, right?
It's an endless possibilities.
Endless possibilities.
Yeah.
And so, a GE plant that covers hundreds of acres, right?
Yeah.
Building jet engines. You could take, a huge building and make it the size of a box.
Right. And that's
But it has to be a very precise box.
That is like the ideal manufacturing process.
Yeah, but this is way into the future. So at that point in my book, I was looking into the future, and I was writing it for, the younger generation and the future generations.
So what is to say that, ancient Egyptian people found a different way to utilize nanotechnology than we do? Because when we think of it, we think of digital. Everything, we always think about computers.
Right.
That's how we're kind of hypnotized to think about it.
Right.
But if you about like consciousness, the double slit experiment, these things where our attention can literally change the molecular structure of an electron or whatever.
Right.
I can't help but wonder, and again, take a walk on the wild side, that's what we're doing here.
Where is Schrodinger?
Right, exactly, yeah. Wow, I got two of his cats.
Mr. Pickles.
Right, yeah. I can't help but wonder if there is a spiritual technology taking place to where somebody might be able to focus their attention into Saqqara and then have something manufactured atom by atom based on what we've seen in the double slit experiment measurement problem, where everything, electrons, all these atoms, whatever, they are in a wave format, a potential. They're not in one single space until we give it our attention. And then if you have that going on inside these boxes with these perfect surfaces where each atom would know where it's at based on the lid and the four walls, and then you have the raw material coming up from the bottom, and then the consciousness of a pharaoh might be remote viewing what the CIA has done with all that stuff, which is weird to tie into this, but what else would get through electricity-wise through the thickness of these granite boxes? Are they rose granite? The Serapeum boxes?
Are they what?
Were they rose granite?
I think there are different forms of granite. I think there is a rose granite.
Yeah. I can't help but wonder if the designers of whatever was taking place inside those boxes might have been utilizing consciousness itself to build things.
Well, who uses consciousness to build things now?
I suppose we do, but with a lot of extra steps.
We do, but we need tools to do it.
Right.
Well, we use consciousness to access information, to inspire us to build better tools, better machines.
A bridge is on paper
right
before it becomes a bridge.
So we're not imagining these things coming into being.
Right.
Oh, we are.
Well,
originally, yeah, they appear to us fully formed in our heads.
Right.
Where is that coming from? Right. That's a topic of discussion that will take you down another rabbit hole. But there's been a schism in terms of materialism and spiritualism. Yeah. Right. Mm-hmm. And so, materialism is bad. Spiritualism is good. Whereas it's all the same.
This is something that I think it gets troublesome. The Gnostics, talked about matter being evil, and a lot of people might say they completely missed the point because we see. You look at a flower, look at a bee, look at a waterfall. This is the universal law made flesh, so to speak. How could that be evil? I think there's a lot of misinterpretations there. But what I think you're absolutely right about is that there's not a solid line between spirit. A reductionist might call it psyche. So we don't even have to say spirit. We can say psyche. Because that bridge, before it's on paper, it's in the psyche. Right. So there's these steps that we're taking, from mind to paper to tools to material to there being a bridge formed. Mm-hmm. Whereas who's to say that extremely just beautifully minded, advanced people once upon a time realized that there's a blurred line between spirit and matter that can be bypassed. Mm. And what if the technology of ancient Egypt isn't just advanced, but a spiritual technology that doesn't leave a carbon footprint,
Well, what technology isn't spiritual? That's what I would like to know. I mean, there are abuses of technology. Okay. Right? Yeah. I mean, you've got dark energy and love and light energy. Right. They seem to coexist.
Dance of yin and yang. Yeah.
And look back into ancient Egypt to say that dark energies didn't exist, or those dark characters didn't exist back then. I think that would be a mistake.
It would be. They embodied the dark parts too. They've got the papis.
Yeah. Well, you look at the evolution of manufacturing over the last 100 years. Factories and stuff. There is definitely an evolution of social consciousness. Right. And spirit. Sometimes it's been imposed, and sometimes it evolves naturally. But employment laws they're imposed. They've totally transformed the workplace.
Right.
At least we hope they are.
Of course. Right.
And so, a modern factory doesn't look at all like a factory of
Right.
60 years ago.
And that's 16 years. So you, conservatively speaking, 3,500, which, let's say 12,000, there'd be no way for us to even imagine.
Right.
Cell phones are 20 years old.
Yeah.
So if I was to 20 years ago show you a video on my phone on a tiny little screen, piece of glass, that would have been considered alien technology. You would have been like, what?
Oh, yeah.
What's going on here?
Yeah.
So I don't see how there's any issue with people hypothesizing these things for thousands of years. If Egypt, they say they were a civilization for 3,000 years. I disagree. I think it was much longer. But let's say that's the case. 3,000 years, that's about 2,500 years more than we have been making technology.
Right.
Now, there's no input or output into those Serapeum boxes. There's nowhere for wires to go. There's no holes in it. Mm-hmm. So whatever was happening inside of those boxes was wireless,
right,
one way or another. And there's no reason to not hypothesize that this was a technology of the mind.
Oh, and something else that we're also finding out is that the boxes were finished off after, the inner surfaces were finished after they were placed in the crypts, not before.
Okay, the rough manufacture was brought in.
Right.
And then they sanded it down.
And then they installed them in the crypts before they actually gave them the final finish.
Okay. What does that indicate to us?
It indicates that maybe Lauren was correct about the heated water.
Yeah.
Bringing it to temperature, because
the sides would work.
Because if granite, if you finish it at one temperature and then it sits in another temperature, then it's going to change.
And you can't have that.
And you can't have that, no.
Now, if these boxes were meant to be artistic, they are meant to be coffins for bowls, you could have it warp all day. You're fine.
All day long, at night.
Right. But they refused to have even a slightly warped granite. And I almost said slab, but these are one piece of granite. Whatever happened. They'd removed the lid, which was so heavy it couldn't slide out of place.
Right.
The boxes in the niche that it can't.
Well, they knew how to move heavy weights.
Right. They had that down.
They had that down pat.
What do you think they were pulling out of these boxes?
Whatever objects that they decide, maybe ailerons for their UFOs or whatever.
Right. We got a clip of that?
Well, they wouldn't need those. Now, I'm not saying it's a definitive thing either.
Right.
I'm just playing with a little creative manufacturing here.
That's what you're best at too, is showing the information and being like, this is what I'm measuring. And then being like, okay, turn the page a few times and we're going to walk on the wild side here. This is what it could have been used for here and there.
Take a wild side.
Yeah.
Know your place. That's another section in there.
I always tell everybody to remember their what ifs. If they're going to say something wild, put a what if in there.
You wanted to talk about the Petri Core number 7.
Yes.
And also the SAR scanning.
Yeah. Okay.
So which one first?
Let's do the SAR scans. This is something that is new and alien to me. Unless there's do we have to talk about the Petri Core first? I mean, that's been covered quite a bit, but I'm open to it. But the SAR scan thing, I'm curious about.
Let's do Petri Core.
Okay, fine. I've been looking forward to hearing you talk about the SAR scan now for like 2 weeks. All right. We'll save best for last. All right, that's what we'll do.
Well, both subjects can be very, very short.
Okay.
Okay.
I don't mind long, but...
Yeah, but I do.
All right.
Well, the Petri Core has been... It was ticking along real fine.
Mm-hmm.
And and it was, you know, Ben produced his video, which I thought he did a great job. And it was fairly solid. Basically a wall of silence from academia in terms of that. And then along come these Russian researchers, and they wrote a paper on the Petri Core number 7, and they claimed that it was not a spiral, but it was horizontal.
Okay.
So basically what they had done is they had taken a series of photographs, or had somebody take a series of photographs of the core
Yeah.
at
The lines.
various locations around
Yeah.
around the perimeter. And then they'd taken those sections of the photographs and laid them flat in their computer, and then displayed it as a very, very confusing and rough kind of picture of the core. Well, their methodology was just wrong. They had the bright idea to take this panoramic view around it and then analyze it.
Yeah.
Okay, so I looked at that and I was like, okay, you're wrong on two points there. One is, like, this is pretty much the size of the Petri Core number 7.
Okay.
If you take a 2D photograph of that and you centered right there, when you look at that photograph, this surface right here will be arced.
Yeah.
And this surface right here will be arced, right?
Yeah.
And all the lines in between will be shifted. It's an optical distortion
Yes.
in the photograph. So that is a strike against it right off the bat, right? And I made a series of cones to demonstrate what would happen.
It's an ancient Egyptian relic right here. Survived the test of time. It survived thousands of years the same way that passport did at the bottom of the road at 9/11. We're going to take that out.
No black box.
So basically, I created a cone, you know, just drew it up in my CAD program, put a series of lines on it,
Yeah.
and then dropped it on here,
Right.
right? And so you'll see, taking a 2D photograph of that, and then creating another cone, breaking it into 6 sections. You can see there's all kinds of problems with it.
Yeah. That does not. It
It's
doesn't
waving
appear
back
to
and
be,
forth.
Yeah, concentric. It's no longer.
Right, right. And that's because of the radii, the optical distortion creates
Right.
the radius. But a question. When is a spiral not a spiral?
I suppose whenever it's unraveled.
When it's cut into little pieces.
Right. Okay.
Okay. This is a pipe thread. It's got a pipe thread on both ends.
Gotcha.
So we know that these are spirals.
Right. They have to be to function.
If you want me to prove it, you can get some cotton thread and I'll wrap around.
No proof needed. I'm going to take your word for it. This
Okay.
is a spiral.
So we know that that's a spiral.
Right. Like, wait a second. Well, yeah, because it starts somewhere and then it continues on
Right.
its path. Right.
Okay. So there it is. We know that that's a spiral.
Right.
Okay.
Okay, I see what we're doing.
So we
Okay.
cut it into pieces,
Yeah.
and we lay the pieces side by side.
This is no longer indicative of a spiral whatsoever,
No.
because the gradient from the top of this spiral moving downward is so subtle
Yeah.
that you can only tell it's a spiral by the activity that you're
Right.
going to get whenever you run your finger through it. And
Right.
it takes me several
You can trace it
rotations
down.
just
Right.
to get it this low from the top.
Right.
Whereas right here, what we're looking at appears
You're
to
just
be
looking at a
straight
bunch
lines.
of pieces.
Right. So if I was to align these as a photograph, I could align them in such a way that they appear to be straight lines.
Well, yeah, absolutely.
And that is what that looks like here.
Looks like that, right?
And this is going to...
You just destroyed your evidence, too.
Right. Because, okay, for the Petri core to exist, and that has to be a spiral to come down the stone, hollow it out, and then you break away the debris, and you could pull up what you have. You have the hole in there,
right,
and that requires a spiral. And their way of saying that it wasn't technology, it wasn't a machine, is by saying, well, there's no spiral here.
Right.
And their proof of there being no spiral is these 2D sections of photographs that they took.
Right.
Is this on purpose?
The conspiracy theory. They ignored the method that I used.
Right.
Which was wrapping a thread around the groove.
Right. Which follows.
Which worked.
Yeah.
They said, no, we're not going to do that. We're going to try a totally different way. Well, if you were going to falsify a method in a scientific experiment,
right,
you use exactly the same methods and tools that the original investigator used, right?
Right, yeah. And then
But they didn't. Nobody has. They created a video for YouTube, and it was they go by the name Scientists Against Myth. And their clickbait thumbnail shows me, Ben Van Kerkwyk, one of the investigators who looks like a superhero, and then some alien and an alien craft in the background.
Oh, they're throwing mud at that point, putting an alien in the thumbnail. So they're giving people's attention. They're going to put your face next to an alien being or UFO.
Right.
And all you're saying is that follow the thread on this core, and you will see indicative evidence of a drill, a machined drill, and there's no way around it. Their best way to debunk that is to shred the evidence, hold it in such a way that is incorrect, and then put your face next to a UFO.
Yeah. Oh, with also the headline on that video is 100 Years of Deception.
What's that supposed to mean?
Well, it means that they're not just accusing Ben Van Kerkwyk and myself of deception, but they're going back and including Petri too.
Really?
My second examination of that core, I was with a geologist, Malcolm McClure.
Okay.
And he did the same thing.
Yeah.
With the thread.
Right.
He traced it around the grooves.
Right.
And he got 16 turns in, and he said, I'm speechless.
Right.
Right?
Yeah.
But then, being a geologist, and I can understand that a geologist would want to photograph around a core to study the geology of it.
Yeah.
Right? But this is not just geology, it's geometry. Mm-hmm. Right?
Yeah.
And also features that are applied on a truncated cone. Mm-hmm. But anyway, so Malcolm, after using the thread, he said, well, I think I would like to take a series of photographs around the core.
Sure.
And he did that. Mm-hmm. And he stitched them together. And he sent me the photographs. Well, I knew immediately that was not the way, and I didn't even mention that he'd done that.
Right.
But I have the photographs that he sent me, and they're in the presentation that on the Petri Core.
Is there a video of the Petri Core rotating, being spun? Because
there has been a recent research by Adam Young and a Swiss guy, an engineer called Caroli.
Okay.
They were recently in the Petri Museum and examined the Petri Core. I'm not sure if they spun it, but I know that they took some. They scanned it, 3D scanned it. I'm waiting for their report or their paper to be published. The other thing is in 2000, 18, two engineers from Rolls-Royce went to the Petri Museum,
Okay.
and they also examined that core.
Yeah.
And they said it was a spiral. Not only that, other cores that they examined had spiral grooves too. There's an expanded article on my website on that research at gizapower.com. And let's see, what else? Oh, you may remember the Graham Hancock and Flint Dibble debate on Joe Rogan. Mm-hmm. And during that debate, Flint Dibble, Joe was interested in the core drilling.
Yeah.
And so he brought that up, and Flint Dibble said, "Oh, that's already been debunked. Scientists against myth have debunked that." And
so why even bother?
And so that kind of dropped.
It's kind of drama.
I know, you wouldn't think that it would create all this fuss.
Right.
But you see, the thing is that, the academics are so desperate to debunk everything.
Debunk everything.
They debunk everything right off the bat.
It's just,
Doesn't matter what it is.
There's no, that's not scientific method, by the way.
Oh, no.
This is a huge problem I have with people throwing around the word science. People say things like, science is right no matter what you think. Okay, not the science that's bought and paid for. Right. The scientific method is frankly ignored whenever scientists, have a result that's already bought, like sugar is completely safe, you remember that. Right. Or they already understand, they already know what the result's going to be, so they change their variable just a little bit to get that result. To me, that's not only deceptive, but that's dogma. That is a materialist religion.
Mm-hmm. I think the saving grace of scientists against myth, or at least the originators and the writers of the paper, is that one of the researchers was a geologist.
Okay, right. Well,
so he was doing his job the way he thought was best.
They've got a geologist. We've got a geologist. Everyone get a geologist on your team. It's your mascot now. He's a big hat that says geologist right here. I'm going to say, all right, what we just did with this spiral is real. How do we know? Look, he's holding up a PhD. If you go to school for 8 years to learn about something, to be a professional in something, you are now a professional in what they've told you to think. You have now memorized all of the things that might be outdated. You'll have no idea. You sat in the classroom, instead of going out into the field and reverse engineering these things yourself, you watched a damn teacher present a class based on what he thinks is the answers, passed it down to you, and now these people with a master's degree in whatever are regurgitating that information that they learned without having ever put their hands on a damn core themselves.
I got you all riled up.
Yeah. Well, it's one thing when I'm reading your book and I'm like, woo! But then I got you sitting in my living room. The SAR scans are, okay, first of all, they're amazing. But there's a lot, it splits the crowd.
Yeah, it does.
What's your take on the initial scans? What did you think?
Well, I was flooded with requests, right?
Yeah.
I mean, people were emailing me saying, hey, this supports your theory, blah, blah, blah. Can you comment on this? And so I wrote a post to Facebook, and I posted it on my website.
Okay.
Basically, saying that I'm not qualified to judge whether it's real or not real.
Safe move, right?
Right. I have. I would really love to understand how they can take the raw data from that scan and produce such high definition CAD drawings. All right. And basically, that seemed to satisfy the people. It was shortly after that I was contacted by Manu Seyfedeh, a researcher, Egyptian researcher, a really smart guy, scientist, but he was actually working with ChatGPT, and he understood the technology, and he believed it. There's a lot of from talking to him, there's a lot of misunderstanding and overreaction by a lot of skeptics, and
On both sides.
on both sides, yeah, those who want it to be real and those who don't want it to be real. I mean, you're talking about statements coming from Zahi Hawass that were basically
Visceral.
dismissing it. But then he was working with ChatGPT to research its connection, how they would connect with the Giza power plant in terms of their function. Mm-hmm. And he shared with me his conversation and how it evolved. And it was then that I really started to see the significance of it.
Okay.
I still have that part of me that says, you know, we have remote sensing. I'm not an expert at that. This work has been peer reviewed and papers published on it.
Okay.
The whole Filippo Biondi is one of the principal researchers behind it.
Right.
But Manu was convinced that it is accurate.
They were able to verify certain chambers in the pyramid that are known with the SAR scans. They show up.
The other part of it was that they had revealed features inside the Great Pyramid previously, and then also inside the Khafre's pyramid, which was the topic of conversation here.
Yeah.
That reveal structures within the Khafre pyramid that are similar to the King's Chamber complex in the Great Pyramid.
How did you feel about that?
Which is amazing.
Did that add up for you? Were you like, oh, of course, there's a chamber, a King's Chamber of resonant stones?
Well, again, I'm of the mind that, okay, so we're using a technology that I don't understand. I'm not an expert at.
Right.
I can't verify its correctness.
Right.
But the connection to the pyramid power theory began to unfold. Talking to Manu, what we have are these really deep shafts and columns going down into the earth.
Right.
And penetrating through the sedimentary layers, the limestone, and the shale,
and the water table,
and then into the granite.
Yeah.
And even further into the granite. So
mind numbing.
And then the dimensions of them, they're 648 meters deep and about 10 meters in diameter. And if you look at that and figure the fundamental frequency, treating them as like an organ pipe or something like that, a closed pipe. Yeah. Their frequencies are harmonic of the frequencies of the ascending passage in the Great Pyramid. It's like 0.265 hertz. Really? And the Robert Porter, who was taking measurements in the Great Pyramid, measured 2.65 hertz. So. Okay. A really close match. So that made me sit up and to take notice, right? And then when I started to think think about what this meant in connection with Friedemann Freund's discovery and his research in the the lithosphere, the igneous rock. If it's put under pressure, it will turn into a battery.
Okay.
Right?
Right.
And so it releases all these positive Hall electrons that shoot to the surface.
Yeah.
And Friedemann Freund was doing research on earthquake lights.
Yeah.
Because he thought that, by studying earthquake lights, you may be able to predict when a earthquake is about to happen.
Yeah.
Rather than just measure it after it happens.
Right.
And so his research is peer-reviewed. It's many different articles on it. An excellent video on YouTube, TED Talk in Christchurch, New Zealand.
Yeah, I've seen that one.
Right. Mm-hmm. And so here we have a source of electrons in the lithosphere, and the Giza power plant model had in the subchamber a mechanism to drive pulses into the earth.
Right.
Right?
Yeah.
And connect harmonically with the earth. This is where it gets interesting.
Yeah.
What Biondi et al., if their research turns out to be factual, I mean, physical evidence is found.
Right.
It really puts the Giza power plant on steroids. Right? Because what you have is you're not driving vibrations through layers of limestone until it impacts the granite underneath. You're actually driving that granite mechanically directly inside the granite, inside right where the source of the electrons is.
Yeah.
Right? And so that really explodes the whole idea of that entire plateau being served as an energy source.
Right. A cavity would create a resonance it would be both musical and piezoelectric at that point.
Well, it's not actually. It's not so much the piezoelectricity. Okay. Because in Freund's research, it's any igneous rock have these what they call peroxide defaults in the minerals. Okay. And it's those minerals that when they're shook up, they will release these pee holes that shoot to the surface. So, and one of the materials that he tested in his lab was gabbro, which has no silicon quartz crystal in it.
I see.
And it was more effective, more efficient.
Really?
Yes. So here you have, I think, this is where piezo and the Freund effect collide. Right?
Yeah.
Is it piezo or is it the Freund effect?
Why can't it be both?
Both. I would say it could be both. But, there has been an argument made that, well, there's not enough piezo in the granite to have any effect at all, which kind of weakens that theory. And then another part to that is that the silicon quartz crystal has to be stressed across certain axes in order for electrons to flow. Okay. And so because the quartz is randomly oriented in the granite, then you don't have 100% surety that you're going to get piezo out of it. Right. So the whole piezo issue was a bit troublesome to me. Yeah. And but I recognized that there were questions about that, and I addressed it in my new book. Mm-hmm. So, in a nutshell, I would say that right now, I'm really pumped by it. I mean, this is like huge. Right. and I think that they should pull out all the stops looking for entrances to that area. We should,
What are the stops?
What are the stops? The stops, I think, are political.
Yeah.
It's an archaeological site, right? So, you have very, very deep shafts. The whole plateau is, around the pyramids is riddled with them.
Right.
And, does one of those shafts lead to these structures? There had to have been access to them. The other thought that came to me, which is, I think people will just kind of blow their top when they hear this. But
okay.
If you are cutting out all this limestone, I mean, you're talking tons and tons of it, right?
Right.
And you're getting into the granite and you're cutting out the granite. It's commonly held belief that the granite that was in the Great Pyramid came from 500 miles away.
Mm-hmm.
What if they were just lifting it out of the hole?
Okay. Oh boy. I can't say I was fully prepared to hear that. Hold on. Because the quarry has always been a problem. It's always because they're going over rivers, they're going over mountains. How did they get several 70-ton stones, not only up into the king's chamber, but how did they haul it 500 miles? What if it was local and it was deep in the sediment?
They just went right through the limestone and grabbed it. Yeah.
So is there any way to know that there's granite, that it's limestone?
I think the only way to find out would be to find one of those deep shafts and go down it.
Yeah.
Yeah. There's a lot of questions. And I can understand where people would be skeptical because, even as I'm talking now, I have a certain amount of skepticism.
Right. For there to be 8 hollow tubes beneath a pyramid, what does this mean for the power plant? I mean, if we look at an organ, like a pipe organ, like you're talking about resonance there, like this would put the entire purpose of the pyramids into overdrive. It would have been a whole nother power source.
Exactly. The more efficient power source.
Right.
Right.
Instead of just harnessing the vibrations of the earth itself, which is feasible, now all of a sudden you're harnessing the resonance of these.
And everything else in the Giza power plant stays the same.
Right. So they just released scans saying that there's tubes underneath all of the pyramids, is what they're saying. Does that,
Yeah, there's 8 under the Khafre's pyramid. There's 4, I think, under the Great Pyramid, and 2 under the Menkaura's pyramid. And then they found one under the Sphinx, too.
Right.
More recently.
Which the Sphinx has always been rumored to have,
Right.
They even say that there's that Thoth or whatever left his emerald tablets or whatever underneath the left paw of the Sphinx. So do you think that there is a great leap between the raw scan data and the 3D models that they released?
Well, like I said, I don't know how that was extracted.
Right.
So, but I may find out because there's going to be a conference at the end of September in Wadsworth, Illinois. In the pyramid.
Yeah.
And the Italian SAR team are going to be there.
Okay. Are you going to be part of this, or?
Yeah, I'm going to be there.
All right.
Yeah.
Whenever they showed the 3D model of the tubes and they had a spiral around them, and now if you look at the raw scans, you can see that there is something going on there, but the sharpness and clarity that they put into those 3D models it's a little, dare I say, too good to be true, almost.
Yeah, that was my initial thought too.
Right.
Too good to be true.
Right, but so is the King's Chamber. So is a lot of the stuff that.
Well, it's the kind of thing that. All right, so we don't know anything about the Great Pyramid existing. Right?
Okay.
Never heard anything of it. And then suddenly a report comes up. Nobody's seen the Great Pyramid, nobody's visited, nobody's walked through it. And suddenly a report comes out that describes it and what it contains. And how far would that go?
Yeah, I think it would stop pretty quick.
Because we're so used to it and all the research that has been done on it.
Yeah.
That we accept that it's there, but it's almost like, I mean,
you can't
just look at the Great Pyramid.
Right. You can't run a cover up on 500,000 tons of stone. You can't cover it up. You can mislead people, whether it's intentional or not.
Almost 6 million tons of stone.
Yeah. It's hard to throw a tarp over that.
Right.
Whereas these tubes, these hypothetical tubes, are under the ground, which is going to be a lot more difficult to confirm and verify. Is there anything you can think of else that would be worth mentioning? Anything that we might have missed?
Oh, wow. No, you actually did cover a lot.
This was a very detailed and thorough, I think.
I mean, corners in a box. Come on. Cornered me on a corner.
Right. That's what I do. I want to dig deep into it.
So we done now? Are we done with done?
I think we might be about there, man. Write a fourth book if you want to. And once you have that puppy ready to go, maybe come back.
That is a threat.
Can I write the foreword? No.
I don't know, can you?
Hey.
By the time it's out, you may be like riding high. You may not have time for it.
Okay. All right. But, hey, keep me in mind. I mean, that's a stretch, but I'm open to it. I'll tell you what. If I've got 1 million subscribers when your book is ready to be released, can I write the foreword to it?
I haven't seen any of your writing yet.
Do we have Book of Wonderful Suffering? Where are we at? Sir, I would like to present you with the gift that is for you.
Oh, look at that.
Hey, book for book, right?
That's awesome. Where's my glasses?
Right here.
No.
Snuck that one up on you, huh?
Cheetahs on.
You're not going to read that. I know you're not going to read it. Unless you do. But that's my little ode.
Rubbish.
To the You know what? At least it came from a credible source. I can accept that.
That's great.
But no, please do take that.
So you can write.
Yeah.
All right, then I guess.